Good afternoon, everyone. I'm Rosalind McGregor. I'm the incoming chair, or I'm now the new chair of the Northern Branch, and this is our first seminar webinar. I hope you're all going to enjoy it. I'm going to hand you over to John Beach from iLine, and he's going to take over from here.
Okay, thanks very much, Rosalind, and good afternoon, everybody, and I hope you're all okay. My name's John Beach. I'm from a company called iLine. I'll explain that in a minute. My background is I'm ex-Severn Trent. I used to be Severn Trent operations manager. I then left there 20 odd years ago now and worked for a company called In Situ Form, doing trenchless technology. Spent a lot of time up in the north. We were based in Ossett near Wakefield. Spent, as I said to Rosalind earlier, spent a couple of years up in Scotland doing renovation of all sorts of types throughout Scotland. And then some 10 years ago, I joined iLine as their marketing and business development manager. So iLine, we are a trenchless technology company specialising in renovations of culverts, sewers and pipes, anything up to 7 metres in diameter, so pretty big stuff. We've been doing this now for over 25 years with the same team, so we're a very experienced company in what we're doing. What I'll do is I'll just give you a couple of slides about iLine, and then I'll start to explain. There's two techniques. I'll speak for about 20 minutes about the one technique, then stop and let me ask you some questions, and then I'll finish off with another technique. I'd be grateful if people could mute their microphones. I can hear somebody speaking now. You mute their microphones, and then until I stop, and then we can ask the questions. We offer our clients proven techniques. Both the two techniques that we're talking about is a cured in place lining system and a GRP segmental lining system. The cured in place lining system will go up to 2 metres in diameter. The pre-made GRP segmental lining goes up to 7 metres in diameter. iLine, we are contractors. We do a lot of work in Scotland and we do work in Ireland. We do work all over the country. But we have what we call a can-do attitude. What we're trying to do is deliver jobs on time. We're trying to deliver low carbon emission solutions with minimum impact on the environment, minimum impact on the public. One of the things that we say to a lot of our clients is nothing is too much of a problem for us. You can send us any particular project you've got. It doesn't cost you anything. We'll have a look at it. We will often visit site and we will give you an idea of what can and can't be done. We know we have to tender for work, some we win, some we lose, but that's a free service. So you're thinking, well, I'm not sure what I can do with this pipe, I'm not sure what I can do with that. You can send them to us and we will give you some sort of idea of what can and can't be done. We're based in Northampton with the workforce coming out of Wales. We work all over the country, Scotland, Ireland, the Channel Islands. We do some work abroad, but only if we really like the location. We turn over about 3 to 4 million, so we're not particularly a big company, but we do all the installation work ourselves. And the only thing we specialise out is things like laser surveys and point cloud surveys, which you'll show later on. So just to summarise what iLine do, we can do all the design and all the engineering verification. We can do all the CAP checks. So, you've got problems, we've got all the insurance, all the knowledge, all the experience to do that. So these are trenchless solutions that we're offering our clients. The first one is a cured in place lining. This will go up to 2 metres in diameter, lengths up to 350 metres. You can do other things like patches, which is a small, if you've got an isolated joint, we can do patches up to 1.2. Then the big stuff is the GRP segmental lining. This is all sorts of shapes and sizes. I'll explain these in more details in a minute. And this is all sorts of shapes and sizes up to 7 metres in diameter. Then just for our point of view, we can repair the head walls. We can do some civils work. We do pressure liners. We do pressure liners. We're actually just about to start doing a pressure liner up in Grangemouth for a fire main. We've done rising mains. We are trying to work with. We were part of the development of a gas pressure liner to work with Caden. Have used it with Morrison's, and we are currently still in the process of developing a solution for gas. But we also do CCTV, survey, cleaning, but everything we do is portable. So what we are, a trenchless company doing a variety of solutions, trying to get to all sorts of locations. So that's why all our equipment is portable and non-disruptive. That's the main idea, the main philosophy of where we come from. And this is typical of what we get. This is typical of what clients come to us. The pipe's cracked, it's fractured, it may be deformed, it may well be collapsed. It can be like this, it can be bricks, it can be all sorts of materials. It can be Armco, these are up in Shetlands. It could be these are up in, these are when we were talking about Mull, these are places, these are in Mull. These are culverts, so you can see the stone, it's all falling in. Now, this is in York. If you imagine you're going to try and repair this, if you try and dig on this, the whole thing's going to collapse. So what we're going to do is we're going to clean it and we're going to try and restore the structural integrity by using the existing pipe as a former. So this is where iLine and these techniques come into account. So, you know, this is just a typical example. That's the pipe, that's the finished product. So from iLine, you know, as I said previously, we're specialist contractors. We can do all the design, we can do all the site visits. We always like to visit site because it's our responsibility that if something's wrong. We also need to, because we're going to do things like topo surveys, eco surveys, because we need to understand, you know, the ecological systems around the area, the badgers, the bats and stuff like that. We need to understand all of that. Plus the fact that because we're going to use the existing pipe as a former, we are going to reduce the capacity. So we do need to talk to people like the Environmental Agency, CIPP, these sort of people, your flood risk people. So we're not going to cause any further flooding. So you can see with all the rain we've had just recently, the last thing you want to be doing is having a pipe which is going to reduce capacity, which is then going to cause further flooding, further damage to properties and stuff like that. So we can do all the flow calculations and the land drainage applications. So specialist contractors offer various services. Our client base tends to be, we don't do a great deal for the water companies, but we do some for the water companies. But our main clients are Network Rail, Environmental Agency, Highways England, BEAR in Scotland. It's National Highways now, they keep changing the name. The councils and county councils, canals and trusts, petrochemicals. We've just finished nearly 7 years. I've been still involved. I've been in the Shetlands doing a lot of work up there. So there, and airports and private and manufacturing businesses. So we cover a whole range of clients. Just really before I go on to the techniques, we are a construction line gold company, builders profile premier, so you can see this is the quality that people ask for these days. Our crew's basically a mining background, so we do confined space, we can do rescues. We've done over 400 culverts for Network Rail over the past 5 years, so you can see a lot of experience in what we do. So let's just start now talking about the technique. So before we start, we need to understand what's going wrong. So we need a proper survey. I mean, I don't mean a 5-minute survey, I mean a proper full survey. So we can look at what the problem is and what the solution or solutions are to resolve that problem. I can't emphasize this enough. The number of times we get surveys sent to us, which are basically, you put them in the bin. We need to understand what's going wrong. The pipes we're looking at here are what we're going to talk about. I'm not going to talk about pressure pipes today because that's a completely different thing, but that's something we can do in the future if that's needed. But we're talking about gravity pipes here. These are sewers, these are culverts under railways, highways, rivers, all sorts of materials. Now, we're not going to bond this liner to the existing pipe. We're just going to use the pipe as a former. So it doesn't matter what the material is. So it can be concrete, clays, bricks. It doesn't have to be circular either. It can be egg-shaped, square-shaped, rectangular shapes. So anything up to 7 meters in diameter, we have potential solutions. So all sorts of locations, all sorts of host materials, all sorts of shapes and sizes up to 7 meters. As I said earlier, 90% of people come to us because the pipe's fractured, it's cracked, it's deformed. It may well be collapsed. We do have solutions, even when it's collapsed, that we can resolve things. Hydrogen sulfide attack. The next bit, then smaller, you know, might be infiltration, exfiltration, which can lead to roots and collapses and blockages and overflows. Well, I don't know if any of you saw California yesterday where you've got a sinkhole, our sinkhole here. This is in Woking down in Surrey. It's not as bad. Or the train ride, that would be an interesting train ride. Don't worry, that's New Zealand again. Not going. But once you've got them situations, you then have your various options. You can do your traditional way. You can dig down on it. That may be your only option you've got. You know, you may have to dig, or we can try pipe bursting it, or directional drilling, or we could try the lining technique. Put a structural line into the existing pipe to try and minimise the delays and disruption. These are low carbon emission solutions compared to open cut. So this is becoming more and more important these days with carbon emissions and carbon neutrality and all that sorts of thing. So the first solution then, which I'm going to talk to you about, is the cured in place GRP UV cured in place lining. This is a bespoke product designed to fit tight into the existing pipe. Now, for those of you who don't know what a cured in place lining is, it's a tube which is manufactured out of glass or felt, which is then impregnated with a resin. The resin can be a UV resin, it can be a hot cure resin, a thermal resin. It's pulled into the existing pipe. It may be inverted into the existing pipe with water, and then it's cured. And then once it's cured, it replaces the existing pipe. So it's an open-ended tube, or either a resin or a thermal resin, cured in place and then replacing the existing pipe. It's designed to replace the structural, up to 7 meters to give you fully structural. It results in a jointless, seamless, fully structural standalone pipe within a pipe. It is designed also to give you a 100-year design life. You can have now, there's a new liner come out which is 120 years. These are independently tested, but we design ours to be fully structural standalone. Now, you can get a structural liner which still relies on the existing culvert to take all the loading. Some clients still want that, some clients do want that, but we design ours predominantly to be fully structural standalone. So when it's cured, the existing pipe becomes redundant as far as the loading is concerned, and the liner takes all the loading and replaces that pipe in total with 100 or 120-year design life. So you can see pretty big, different shapes, odd shapes like this. Now sometimes this is in Manchester, Edale, I don't know if any of you know that, but you can see here the culvert is going all over the place. Now, what we're going to do is put a compromise liner in here. We can't put a liner that's going to fit exactly all over the place because the liner is going all over the place. So we put what we call a best fit, and then we grout it in position. All the grout does is transfer the loading onto the existing pipe. So these are the factors which we take into account when we design the liner. We look at the hydrostatic head, the water table. We look at the live and the dead load, the Eurocodes, LM1, LM2, LM73, LM74, depends on if it's roads or rail or highways, and ovarity. All those go into an equation which gives us a thickness of liner we need to resist that loading for the 100-year period. We then look at the nature of the effluent. We have 3 resins we can use. We have a polyester, a vinyl ester, and epoxy. Each one has different characteristics. So if it's rainwater, we can use polyesters, but if you've got nasty natures of effluents and stuff like that, we can vary the whole thing. So the whole thing is a bespoke product designed to give this fully structural standalone product with 100 or 120-year design life, with a very smooth coefficient of friction. This is the Manning's 0.009, the Culvert White 0.028. So if I just explain to you now what you lose here. So because we're going to use the existing pipe, we're going to lose a bit of capacity. Now this is a 900 Armco and a 900 brick. We're going to put a 900. Remember, these liners are bespoke. They can manufacture them to whatever shape and size you want. They don't have to be 900, they can be 905, 9010, 880, whatever it is. But in this case, we're putting a 900 in. It's 15 mil thick, so we're losing 8% of our capacity, roughly about 8%. Because of the smoothness of the coefficient of friction, against the Armco, we've improved the flow by 220%, against the brick by 150%. So this is where we need to be sure that although we increase the flow, we're not causing a different problem. We're not causing scouring and stuff like that. That's where we have to negotiate and talk with the EA, the flooding people, etc. The process itself. Right, first of all, you've got to clean the pipe. You've got to measure it. You've got to find out where your connections come in. So the cleaning can be quite simple, quite complex, can be a high pressure jet, can just be a drag scrape, could just be a flush. We've got to measure the pipe to make sure it's exactly what diameter it is and what size it is. So when we order the liner, we're ordering the right thing. The liners themselves, we use GRP UV cured in place linings. So these are manufactured in Germany. They're manufactured out of a sheet of glass fibre, which is impregnated with a UV resin. Now this UV resin reacts to UV light only, so it doesn't cure by itself, it doesn't cure by heat or cold, it only cures by UV light. So today, where I'm looking at, it's raining, and we're not going to get too much UV light, but it needs UV light. The process itself of manufacture is a continuous, seamless construction. The materials have been tested for a 100-year design life with a third-party accreditation. The length's up to 350 meters, up to 2 meters in diameter. So these have got up to 2 meters in diameter. It comes in a box. On average, because they come from Germany, it's 3 to 4 weeks delivery. And we can, if it's a pure UV liner, which means if we're only using UV resin, we've got 6 months to install it. So we've got through till the end of June, beginning of July to install this liner. So we've got a lot of flexibility in what we do. This is just showing the manufacture. So sheet of glass fibre, resin impregnated into it, and then we manufacture the liner like this. This is how it's manufactured. We have a machine which is set to the shape and size. Onto it, first of all, we pull it in foil. This is like a heavy clear plastic bag. We then wrap the impregnated layer of glass fibre around it to give us the required thickness. It's a spirally wound, keeps going. We then wrap a wearing course over the top, and then we put a UV protection foil over the top of that. So we have an inner foil, glass fibre layers, a wearing course, and an outer foil. That then gives it all the protection. It's an open-ended tube, so all the chemicals are sandwiched between the inner and outer foil. So from an environmental point of view, it's very safe and friendly. And it comes like this in a box. So this is one of the ones we did here. You can see the box, and it tells us everything we need about it. It comes with a sheet. It tells us for iLine. St. Pierre is near Chepstow. It's a 1.6 metre diameter, 24 mil thick, 14 metres long. Now, we're going to cure this using lights. We're going to use UV lights to set off the chemical reaction. It's called the exotherm, to turn it from a liquid form to a solid form. Now, to do that, we need to be sure that we set the lights at a right speed to pull through, so we cure all the way through the liner. If you imagine 24 mil thick, it's quite thick. We used to work that out, but today, like going shopping, all we do is scan that barcode and it tells our computer exactly how to cure the liner, exactly what's needed. It also gives us an audit trail of where the liners come from, etc. On site, everything is portable. You know, the liner comes in a box, a set of lights and a control unit, a rubber duck and a high hab, and a winch and a compressor if we need it, etc. You need access at both ends, but it's a very small footprint and it's very non-disruptive. You know, you can see the trains are still running, the roads are still running. You know, there is a very small footprint here that we're going to use. With this process, you've now got to stop the flow before you install the liner. The pipe doesn't have to be dry, but you need to stop the flow running through it because we're going to block it off while we put the liner in. So that can be quite simple. This is where I live, Leamington Smart, 4-inch pumps, or it can be quite complex where you've got to over pump the flow. It may be just sandbag it or you wait for a drying period, but you've got to stop the flow while you install it. Typical site setup now then, the liner comes in a box, it's concertinaed into the box, it pulls out. Remember, it's an open-ended tube. So one end we need that, the other end we need the winch and the compressor. Once we've cleaned the pipe, we don't want to damage the liner, so we pull in this slide foil here. We pull this all the way through, and then we pull, winch, drag the liner through. We can go through manholes, we can go quite, like I said, 350 metres, but we can probably even do more, but we haven't done anything more than that here. Now, if you can imagine that what we're going to do is expand this liner. Now, because this is that one in York, because we've got massive voids here, if we do that, it's like a balloon, it's going to bubble into it and you're going to lose some of its strength. So what we do is we put the liner inside this pre-liner, this heavy blue bag here. We do the process I'm going to talk to you about in a minute inside that bag. So it's expanded up to the shape of the pre-liner. And then afterwards, we grout the void on the outside to lock everything in place and fill all these voids. We do that deliberately sometimes as well. So you pull this open-ended tube through, you go to both ends, you put a ring in and a plate to seal it off. Basically, you're going to seal both ends off. You then blow compressed air in up to 1/2 bar. This just expands the liner so it fits tight into the existing pipe. So we just expand it, it fits tight into the existing pipe, and away we go. That takes time because the glass has to open and stretch and everything else like that. We're now going to cure it. So these are the lights that we're going to go. So this is a 1.5 metre diameter setup. This is a 450. There's a camera at the front and a camera at the back. The lamps here, they're £2,000 for a set, so we're very careful with them. We don't want to break them. We take one of the ends off. This is just what we call a garage arrangement. It just allows us to pull the lights in without losing too much pressure. We put the ends back on, we repressurise it, and now we don't do anything until we've checked. So we don't turn the lights on yet, we turn the cameras on, and we pull the cameras all the way through to check. Now, if there's something wrong, maybe a brick's dropped in or it hasn't gone up to size, we can put extra air in, but we can see it, we can video it so the client can see it, but we don't do anything until we're ready to go. If we're ready to go, and this is just a setup, this is near Inverness on the A9, so this is it. You can see here the roads are still running. It's a very small footprint, as I said. It's not a great deal of space taken up here, but we're ready to go. The flow can come through there. So if we're ready to go, we're now going to start the curing process. So now we're going to basically scan that barcode. Now, the first liner was put in Hackney in 1971. It's been in over 50 years. There's over 500,000 miles of liners put in place now. We took part of the liner was tested a few years ago, and the liner is still doing as it says on the can. It's not lost any strength, and it's it's still showing it's a good product. This was put in very basic. One of the first ones put in, but there's over 500,000 miles. This is probably even more than that now in place. So we then scan that barcode. Now, a typical job takes 2 to 3 days. First day is to roll up on site, to get everything ready, to clean the pipe, to set the overpumping on. Once you pull the liner in, all curing is done in 1 day. All curing is done in 1 day. So you pull the liner in, and then you scan that barcode, and we start the curing process. Now, this is a cure as you go. It's not like concrete takes time. You cure as you go. You can stop and start. The speed that you cure is based on the diameter of the liner thickness. The lights can be adjusted by the computer if any bulbs go down, but for thinner liners we're curing about 1 metre a minute, for thicker liners about 0.5 metre a minute. So probably up to 15, 16 mil, we're curing about 1 metre a minute, or greater than that, it's 0.5 metre. So if you've got 60 metres, you're talking about an hour to 2.5 hours. So you can see very fast. Once it's cured, that's it. You take the ends off, you take the lights out, let it cool down because it's very hot. You trim the ends to smooth it off, and you remove the inner foil. Now, the inner foil was there just to protect all the chemicals. So the inner foil was there just to give you that environmental protection. Once it's cured, you don't need the inner foil. We put a camera down to confirm that all the cure process has taken place, and also we need to pick up connections. So before we started, we put the camera down. We know there's connections coming in. Say there's a connection coming in at 5 meters down at 1 o'clock on the clock reference. What happens is that because there's no resistance there, the liner dimples into it. So if it's a big one, a man will go and cut it out by hand. If it's a smaller one, we'll send a camera down with the robotics. It'll drill a hole in it. It'll reopen the connection, smooth it off, and then move on to the next one. And then later on, we can come back and put a top hat in or do whatever we need to do. You get a printout of the whole process. If you can see on this one here, we haven't gone up to the full size because there's these lips here like that, and then we'll grout that in place. So we grout all along. This is an anti-washout grout. We will grout all that void all along the length so we can transfer all the loading onto the liner. Just some examples of before and after. This is down in Devon. That's before. Wherever you start with, you're always going to finish up with a very smooth inner surface. So, just to summarise this, and I'll show you a couple of case studies, and then let me ask you some questions. You ask me some questions. So this will go up to 2 meters in diameter, different thicknesses, maybe up to 20 mil thick. We can use the UV resin. Greater than that, we combine resins. The only difference is the process is exactly the same. Is if we use pure UV, we have a 6-month shelf life. If we combine resins, we have a 3 to 4 weeks shelf life. We can do lengths up to 350 meters, various cross-section area. The downside is bends. It's not great on bends. What happens on a bend is when you pull it in, maybe when you pull the camera through, the cable catches on the inside, rips the cable, it may twist, and that causes you a problem. So bends are not great on this process. So from iLine's point of view, we did the thickest UV liner in the world. This is for Wash Farm, Essex highways. This is a 900 by 1400, 11 metre twin culvert. Bricks are falling in, radial cracking, very shallow road. Feeds an industrial estate, and they were not happy because they were going to cause disruption. The road was basically going to be closed for 6 weeks, so they were all looking for serious compensation. So they came to us and said, right, can you put a fully structural liner in? Because of the shape, we worked it out 30 mil, we checked it, everything else, we did cat check in it. We put the 2 liners in 4.5 days, 1/6 the cost. The road stayed open all the time and increased the flow by 187%. So 6 weeks against 1 week, 360,000 against 62,000, diversion against no diversion. And again, in Ireland, for Coca-Cola, we had, this is a 1.8 to 27 metre long by 21 mil thick liner. We had to create a new invert because Coca-Cola has discharged and eaten their invert away. This is the liner going in. This is just holding the ends because of the pressure to grab this up to take it up to the size. And that's the finished product. You can see pretty big, all very smooth under the railway line there again. This is one for Welsh Water. So here, this is a 1280 pipe, 650 metres in a triple SSI area. What was happening really, in quite simple terms, is the tide was coming in. As the tide came in, it infiltrated into the pipe, it knocked out the treatment works. When the tide went out, all the raw sewage came out of the pipe into the river, causing pollution. So basically they said, sort it. So we built all our equipment on a scaffolding. We did 60-metre lengths. We could divert the flow through one pipe when we did the other. We could bring the equipment in, do it, come back the next day and finish it off. It's just speed. And again, different shapes and sizes. That's what you finish up with. You know, you do get wrinkles sometimes. You can't help that. We all get wrinkles as we get older. This is what we did in Scotland. This is for this is not long ago, last year, where the client wanted to extend the pipe. And what they wanted to do is they were going to originally put another pipe. So what we did is we designed a fully structural standalone liner, not a liner, but fully structural standalone pipe that we extended the pipe by 22 metres, and then they backfilled it and used it as a brand new pipe. Highways, that's some of the Armco ones we've done down in Devon, 25 of them. I'll just go on to that. And this is a slightly different application. So here, the structure is okay, but there's no invert. So this is for a scab protection scheme where we put in, because there's no invert. So typical applications, really 90% is to strengthen the existing pipe, to bridge discontinuities, to restore the structural integrity. It may be to eliminate infiltration, it may be to eliminate exfiltration, it may be to stop hydrogen sulfide attack on the pipe. It may be scab protection, extend the existing pipeline. Hydraulic capacity is different because obviously, you know, you are getting a better flow because there's no roots, there's no bad joints, there's no displaced pipes, etc., where you can block everything. There's nothing to maintain. Once that liner's in, there's no joints, there's no seams, it's full, you know, there's nothing to maintain, so it reduces capacity, you know, maintenance. In Leamington Spa, where I live, we lined all the sewers when I was in operations manager 25 years ago because we root cut every day, 365 days of the year. We now don't root cut at all here because we eliminated that problem by lining. And I'll just summarise it and you can ask me some questions. So this is a GRP UV cured in place liner. It's fully structural standalone without digging. It's got 100 or 120 year design life. It's minimum disruption to the public, same day return, it's very quick. All sorts of shapes and sizes up to 2 meters. It's a fully portable system, so you can get it to all sorts of different locations. Minimum enabling works, saves money on over pumping and in enabling works. It's environmentally very safe. Minimum loss of capacity, minimum health and safety risks. And quite simply, it's a new pipe within a pipe with a 100-year design, give you a fully structural standalone pipe, a low carbon emission solution. So it ticks a lot of the boxes, no digging. And Rosalind, I'll pass it back to you guys. And if you want to ask me some questions, and then I'll go on and show you the bigger stuff.
Thank you, John. And thank you very much for that. That was very interesting. And we have questions here. So thank you very much for joining us this afternoon. And I'll just alert John the first question. How do you grout behind the liner?
So basically, it's a pressure liner. It's a pressure grout. It's what we call a reader. It's a 12 kilonewton per millimetre squared. Line. It's a fine grout which we pressure line. So we block one end off and then we just pump the grout in. We weep holes to get it, so we get all the air and just fill the whole thing. We don't grout it all in one go. We grout it in stages, so gradually filling it up to lock it all in place and transfer. 90% of the liners we don't need to grout. We try and make them as bespoke and as tight fit as possible. But where we do, that's how we do it. So it's a very fine grout. There's no heavy stuff in it. It's a waterproof grout which we just pump in, and then gradually it sets very quickly.
Thank you very much, John. And the next question is there any testing done on completion to confirm quality?
Yeah, well, this is interesting. Scottish Water refused to pay for that when we did all the work in Scotland. Some clients do, some clients don't. We offer the service if they don't want it, but we take random samples and have them tested and stuff like that. In Germany, every sample has to be tested. In a lot of countries, in this country, no. So the answer to that is it can be done, it is done, but it depends on the client.
Whether they want to pay for it or not. Typical thoughts.
The biggest problem now, Rosalind, is not so much that. It's because of COVID, a lot of the labs that used to do it closed down. So, you know, the facilities to test now, in the end, we were sending them to Berlin to get tested and all that sort of thing. So it's quite expensive. Coventry University used to do it. Bodycoat in Manchester. Do you know Bodycoat in Manchester?
Yes,
They used to do it, but they, because of COVID, they lost a lot of that ability. So it became more and more difficult to actually get somewhere they could test it.
Okay. Okay, well, that answers that question. So we've got one more. We've got two more questions. Do you know yet if the product will meet DWI approval?
Oh, drinking water? No, it won't.
No. Okay.
So if I go back to my old days in situ form, we tried for 3 years to get DWI approval because it contains an element called styrene. Whatever we tried to do, we had styrene resins and everything else like that. Let me put it to you like this. In France, it's approved. In Germany, it's approved. In Holland, it's approved. In Belgium, it's approved. In England, it isn't approved. The DWI wouldn't approve it. So we can poison our European colleagues, but
not ourselves.
Wouldn't do it. So we've tried, and lots of other people have tried, and so the answer to that is no. It isn't approved. It isn't approved.
Okay. And next question. How do you confirm grout has totally surrounded the liner circumference and the length?
Again, a very difficult question, because unless you do a radar survey afterwards, which is a cost, you can never be 100% sure you've filled all them voids. We've done them in the past where we did trials, we filled them and then dug down them untested, and I would say we're hitting 95 to 96, 97%. But not 100%. I don't think, we can never be too sure. We bleed the air, we do shorter lengths, we bleed the air out, we try and do it slowly so that we're not filling it too fast, and then basically we can never really be 100%, I can't say we can ever really be 100% sure we've filled the voids totally.
Okay. Well, thank you for the questions. Do you want to give another couple of minutes to see if any more questions come in? John, can you just tell me, so the process is suitable for water, so where are you with the process for gas?
So with gas, we've been working with WRC. Do you know WRC?
Yeah.
Yeah. So we've been working with them. We've got a liner. We've got two liners, Reline Europe and Sartex, which are approved to use on gas. So they've been tested and approved to work on gas. We then got to the problem of, because you need an end fitting, you need a flange fitting of some sort. So, do you know PMP? Have you heard of PMP?
Yes, yeah. Yeah.
Well, PMP, they've got an end fitting that works, but it's very expensive. So we've been trying to work on different end fittings. Now, Caden have done a couple of trials with Morrison's, and they've done a couple of already live jobs. We've done a couple of tests down in South Wales. The problem at present is convincing the operations people in gas that this is a solution that will work. And the main concern was that it wouldn't be, we couldn't do it under pressure. Couldn't get an under pressure tapping, and they employed a company called AHL. Do you know them at all?
Yeah.
Yes. And last time they were in the process. They think they've got something, but I'm not exactly 100% sure where we're at with it now. Andy Russell from WRC, has been off, and I said to him I'll speak to him later on this month and find out where we're at with it. But they've got a liner which has been approved. The Reline Europe liner has been withdrawn because they want to modify it, but the Sartex liner has approval, the end fittings have approval, but I think the issue is at present is just trying to convince some of the National Grid people and Caden and people like that that it's a product that can be used successfully and safely.
Okay, well, we don't have any more questions coming in, and thank you very much for that information.
Right, let's go to the bigger stuff, and then if they think of anything, they can ask me at the end. Right, so this is now GRP structural lining. This goes up to 7 meters in diameter. So this is big stuff. This will go from all sorts of shapes and sizes. It can go around bends. It's manufactured out of glass fibre, and it's pushed in. You can do this from one point of entry. You go to the far end and you work your way back. So it's a pre-made solution. It has a spigot and socket. It can come as a whole piece. It can come in sections. You'll see this in a minute. But you are going to push this in, so you are going to lose a reasonable amount of capacity here. You can see from these here, the outer surface it's got it's like a grit on it, so the grout adheres to it. So you can see it'll go from one shape and size to another shape and size, all sorts of things. This is again a well-proven technique, goes back to 1979. It used to be made by Stanton Bonner in Chesterfield, but they stopped manufacturing it where they couldn't make it profitable. It's manufactured with glass fibre, resin and sand. It comes as a whole piece, or it can come in sections. It's manufactured under quality control conditions. You can use this for non-man entry and man entry, so you can jack it in or you can push it in. It has a spigot and socket, so it joins together with the rubber jointing, or you can come in segmental units, and you put it together as a jigsaw, like a tongue and groove. You'll see this in a minute. Starts at 10 mil thick. It's a bespoke product. It's lightweight, it's adaptable, it goes all sorts of shapes and sizes from one point. It's usually manufactured in lengths of 2.4 meters in length, but you can manufacture it to suit whatever your requirements. So you can go 0.6 of a meter, 0.9 of a meter, 1 meter, whatever it is. You can manufacture this to suit whatever it is. It'll go from one shape and size to another shape and size. It'll go vertically, it can go transition, as I said. You can build into it things like mammal ledges, fish baffles, mat boxes. You can line through whether you've got utilities in. You'll see this in a minute. You can't do that with a cured in place. You can actually install this with the flow running through in certain circumstances. Again, it's a 100-year design life plus 450 mil diameter up to 7 meters in diameter. The downside of this product is it comes from Dubai. You can get it from Europe, but basically from Dubai, you're waiting 8 to 10 weeks at present to get the liner. So it's a 2 to 3 month lead-in period. The liner itself is again very smooth coefficient, exactly the same as the cured in place. You do get better flows, but because you need at least 50 mil to get them in between the hose pipe and the liner, you do lose a bit of capacity. You'll see this in a minute. The loading on the liners is designed for the Euro codes, the LM1, LM2, LM73, LM1, LM2, LM3, LM71, 73, 74, depends if it's road or rail. So it's designed for the Euro codes. This is manufactured out of different resins. You can use a different resin on the inside and the outside. Depends on the nature of the effluent, the type of soil. We did some work in Glasgow in a tip where there's arsenics and all that sort of thing, and a very aggressive soil. So you can manufacture these liners to suit whatever you want. Different chemicals, different abrasion, different sewage, different ground conditions. This is what it looks like. So you have an inner barrier. So it depends on what you're carrying. The inner barrier, so the different resins are vinyl esters, polyesters, or epoxy resins. It then has a layer of fiberglass and resin. It has a central core to give it all its strength of silica, sand and resin. It then has a different resin. You can have the same resin all the way through, but you can have a different resin on the outside if you've got nasty natures of effluent. And then you've got a bonded aggregate on the outside. So that gives it something for when you grout it, because you're going to push this in, push in the far end, work your way back and then grout it. So it's an impermeable high strength sandwich construction. It's flexible. It's designed to resist live loads, dead loads and hydrostatic pressure. Now, you can have this. It's designed normally under the WRC to withstand the hydrostatic loading only, and it's not a fully standalone solution. So it's a semi-structural. So all the liner doing is taking the loading from the water table. You can, though, now we do what we have here, we can do a finite analysis on it. So we can have a fully structural standalone. So the units can be designed to take all the loading and replace the existing pipe in total. So, you've got a bond, but you can have a semi-structural or a fully structural. So, it depends on exactly what the client wants. Most clients these days go for a fully structural because if they're going to do something, if it's not collapsed, it may be they're just trying to stop something like infiltration or something like that. So the water table loading is okay. But if they think it's, especially under some of the railway lines, they want to be sure that they've got a fully structural unit. Why do it again? If it gives you 100 years, let's do it properly in the first case. But you've got to grout. This is a low, so that's what I'm just saying. It's a fully structural, it's an independent, or it can be used as a full work. But this is the grouting is a low viscosity, free flowing, rapid setting, no shrinkage, high strength grout. And it bonds. It can be structural, but it can be used as a filler. From a design point of view, you can't really see that properly. But what we do is we send all the information to Channel Line in Dubai. They will then send us back what they think. We don't design it, you don't design it, they do. They'll send us a profile back that they think will fit. So different shapes, different sizes, how to get around bends. This is here, you can see here, you've got a dry weather channel, you've got a linking panel and a storm channel. This is Inverness treatment works, so going over the wall. Here you've got a 60mm one, you've got a dry channel again, you know, and this is, you can see here, you've got this linked panel, so it's not just one piece, it can be sections. They'll send us a layout plan, how to install it. They'll tell us what lengths we think we should install or which direction we install it from. So in some cases, we normally go from one point, but in some cases we might go from a transition point, go both in and out. Flow calculations there, because this is important now, because you are going to lose, you know, here you've got a 26mm liner, you've got 50mm. So if you look at the flow calcs here, this is a 1400 by 1020 Armco. The GRP unit's going to go in. We're losing nearly 20-odd%, more than that, 25, 26, 27, 28% capacity, but we're gaining against flows. Again, the slightly bigger one, 1950 by 1550, we're still losing a lot of capacity, but we're gaining on flows. So it's a horses for courses. Any of you live in Scotland, you know, Sackey Street, Buchanan Street, Princess Street, all of this has been installed all there. Scotland has got a lot of this in place, especially in the main centres, Inverness as well. The hydraulic capacity. Now, because you've got fish, and especially a lot of the rivers, you know, they sometimes, because the flow is going to go a lot faster through here, we can build in these fish baffles. This slows the flow down, so it allows the fish to breathe. So these products are very flexible in what they can do. So once we've got that design, we have two choices. We can either do a point cloud survey, which I'll show you later on, or we need to verify that shape. So we can go to B&Q, buy some timber, make a profile. We're going to walk it through, and then we're going to modify it, and then we're going to send the profile back to them in Dubai, and then they'll manufacture the units. We don't want to be manufacturing the units before we've confirmed. We don't want £200,000 worth of units, which we can't install. They're made by hand. They're all made by hand, and then they're put in a container and shipped. You can see all sorts of different shapes and sizes going around bends. You know, you've got ledges in them. You're going from one size to another size, one shape to another shape, all sorts of different configurations. Pretty big, go around bends. Every unit has got a label on it, so you know where it is when it comes to a jigsaw. This is an egg shape. This is a twin panel. You can see pretty big. Narrow ones again. Now, we're doing a lot more multi-panel with a tongue and groove these days. It can be 2, 3 or 4 panels. Again, they're very structural. It's a structural adhesive. It actually has certain benefits that you can make them slightly thinner, because that, especially if you've got long straight sides, that joint is actually a very structural and strong joint. So they're jointed together. The segments are jointed with a tongue and groove, and then they've got a spigot and socket to join them. But you can see there's that one I showed you earlier, that one with the drive of the channel, the linking panel, the soft 4-piece, 2-piece. You can build manholes into them. You know, you can. Everyone's got a label. There's a 2-piece one again. Look. Now, transportation costs are becoming more and more expensive. So by cutting them, this is a 2-metre diameter. We can get 6 in a container. If we cut them in 2, we can get 10 in a container. We cut them in 3, we can get 16 in a container. It makes a big difference on cost, because the cost of containers have gone through the roof. This is what we've just done before. This is what we've just done. This is a 4.8-metre diameter, 4-piece. You can see pretty big. That's what it looks like. So, you know, we've gone around beds. We've gone from all sorts of different configurations there. So this is Q8. So that's one there. It's a 4-panel. This is Munich. So that's got a dry weather channel. That's 4.8. That's 7 meters. You know, all sorts of different shapes and sizes. All of these units are tested on a daily basis. So they're tested for wall thickness, bending and flexion modulus, tensile strength, spigot and socket fit, hardness and visual appearance. So they're all recorded. This one goes back to 2013. It's still being tested. It comes with an installation plan, so we know where to fit them in. Here, this is D17 to B14, which is here, there. So we know where that unit comes in. This is what we've done for the Environmental Agency. This is down near Ipswich. You can see we've gone round bends, we've gone up in size. So all the configurations, it's fitted together dry, just to make sure it's all okay, then sent to site. And that's what it looks like inside. So you don't need to go to Alton Towers. Come and join us, have a go on theirs. You can just do the invert panel. This is a chemical factory where the invert's been eaten away by the discharge, and then you can put a socket panel in where you need it. So you clean these and then you push them in, you pull them in. This is a machine that gets them in, the big ones. So they're manufactured to suit site requirements, manual handling, etc. But they're always, you push them in because you lost a bit of capacity. So you can see here the machine takes them in. This is their 2.4 metre unit, the Virgin trains on time for once. They may be slightly smaller units, so we push them in by hand. So smaller units, lighter units. They're pushed in, and then we joint them up, and then we grout. Now this is an anti-washout grout. This is done in stages. We grout the invert and then gradually fill it up. We may grout all along in one go, or we may do intermediate grouting points. We're trying to get a maximum. We can, I think the question before, you can never be 100% sure you've got maximum. We're trying to get as much fill as possible. All the grout is doing is transferring the loading. The liner is taking all the weight. All the grout is doing is transferring the loading onto the liner. Again, with utilities, we can accommodate these with this process. You can't do that with a cured in place, but we can accommodate ones running along top or on the top or across. So different shapes, flat bottom. See the utilities there. We can either cut the top of the unit out, slot them underneath, or go underneath for the full unit and then grout in position. This is Bucharest in Romania. We did about 5 kilometres there of X-shaped ones. Windsor. Different shape, you can say you're not going to get that with a cured in place. Vertical ones. This is what we did down in Sussex. This is gone from a flat bottom arch shape round 6 bends to a circular pipe. Hopefully this will work. Yeah. So this is, you can see the units have all got labels in them. The picture quality is not great, but it just gives you an idea of what you've got. We're going to pick up a road gully here. So this is one of the road gullies we're picking up here. That's all done on site. That's not done in the factory. That's all done on site. And then we keep going. I'll just move it around a bit quicker. And then we're going to go round, and we'll go round the bend. We're gradually going round the bend. The units are then cut. So they're particular for each. As I said, they've all got a label in, so you're fitting them together like a jigsaw, really. And as we go round the bend, then we're going from this flat bottom arch, we're transitioning into a circular pipe. So you've gone from one shape and size to another shape and size. You can build in manholes into these, you can do them afterwards, or you can have them pre-made. This is a sewer down near Sidmouth, where it's a small market in town. If you put shafts in to drop this in, this is a 2.2 EA job, you'd be knocking down properties, you'd be underpinning. So with the 3-panel system, you've got spigot and sockets, you've got rubber joints, you can save money. It takes slightly longer to install, but you're saving a massive amount of money, a massive amount of disruption. Just a couple of examples in. So this is Godalming in Surrey. This is a 1920 by 1950 brick arch, structured and sound, but very high flows. All the work was carried out without any disruption. Now, we could have done this with a cured in place, but the flows are pretty high. To overpump this, it's over £100,000 worth of overpumping. It's also, once we put the overpumping in, we have to have security. It's not like probably where you guys live, but here people would want to disconnect the pipes and push them through people's gardens. So you've got to do that. But by using the flow, we could get the units in. Now, the Environmental Agency wanted us to put a smaller unit in anyway, so you can see here to control the flows, because this culvert was built over 100 years ago. So we put the units in with the flow. We then temporarily stacked the flow off, jointed it up, pumped the flow through the middle, and then grouted and saved over £100,000. So it's everything. It has different applications. This is Walsall. This is what we did 2021. That's the diagram. That's the picture. This is the point cloud survey. I'll let this run. This should run okay. So this is the town hall, the civic hall, the swim bath. This is running underneath this area where they wanted to increase the strength. Now, the whole culvert in there has got concrete columns. It goes all sorts of shapes and sizes. They wanted to put a fully structural, but rather than just putting one unit all the way through, we wanted to be sure we're putting the right units to the right place. So everything's bespoke to where we want to go. I'll just let it run. I don't know if any of you have seen point cloud surveys before, but this is it. So you've got in here, this shows us what we've got. And it just, we can pick up the brickwork. All the reed bars in the concrete are all gone, they're all rotten. But we can see what sort of cleaning we need to do. We can see what we've got. Is that me causing it a problem? Oh, we got concrete columns like this. It looks like it's frozen. No. Sorry about this. It just seems to, yeah. Hopefully I'm good for the day. Yeah, no, I'm missing. Sorry, yeah, it'll just lock my system out, so I won't. But you can see from that, that's what we got. So we then we were able to produce this installation plan. So these are the concrete columns. We could get exactly bespoke products all the way along as we were going. From a design point of view, 57 mil thick. So we looked at the capacity, and this is what you got. Again, all the units got labels on, you fit them together, and that's it. That's the finished product. Ulverston in the Lake District. This is under the town, and we put 350 meters of this, different shapes, different sizes. You can see there's the utilities crossing. You can see how much capacity we're losing, but they were basically getting flooding problems all the time. This is a rough old stone. You can see that bricks were catching in it, roots, tree trunks, everything else like that. So we did all that. We jacked the units through, built a couple of access points so we could get in road connections, and then grouted the whole thing up. Again, another one. This is down in Port Talbot, where they got the culverts are far too big. They wanted to put smaller units in. You can see here. These are the bleed holes to when we grout it to make sure we get as much air out as possible. One in Coventry, where this is now where the invert's fine, so we just put a crown in basically, and then we chemically bond it to the bottom and then grouted it in. So you can do all sorts of, so you can do the invert and you can do the crown. And then for you racing fans, this is Silverstone. So this is, in here we wanted to build in a mammal ledge so the mammals could run under the road without getting killed. So this is what we got. So we designed it. There's the map. There's the units. We put them in. We jointed them, and then we grouted it. Again, you can see we put a smaller unit in just because of too much capacity. We put some riprap in to slow the flow down. We got the ledge. One in Essex, slightly different. Now, if we built the ledge like that one there into it, we'd lose about 30% of our capacity. So what we did is we put a full-size unit in, and then afterwards we chemically bonded a galvanized mammal ledge in. So it saved a loss of capacity. We lost about 3% capacity rather than 30%. And we've got to look after our bat friends. We did this in 2021. We did that. We reintroduced the bat roofs, and I know the environmental people have been back, and the bats are back in there now. So the benefits of using GRP. Bespoke products, comprehensive range of size up to 7 meters in diameter, quality assured. It can be fully structural, standalone, so it doesn't rely on the existing culvert once it's in place. You can have a one-piece or a multi-segmental piece. It can go from one shape and size to another shape and size. It can have bends. You can have it manufactured to whatever length you want. It can have different resins. It's got a smooth inner surface. You can have a different resin on the inside and the outside to suit application. You can drill and tap it easily. It's lightweight and adaptable. It results in a lower overall. It depends on circumstances with the cured in place. It depends on locations. Is this about a location? Can we get that there? No, we can't. We've got to do this trackways. Whereas this, you can put it back up a tractor and trailer. It can accommodate flows, utilities crossing it. You don't need to overpump sometimes. All sorts of shapes and sizes. It's got environmental advantages where you can build in mammal ledges, fish baffles. Again, it's a 100-year design life. The downside is where it comes from. You've got to wait 2 months. Well, I'll just summarise iLine, and then I'll let you ask me some more questions. So, although we're a relatively new name, the same team have been doing this for over 20 years. We've got all the experience, all the knowledge to identify and produce and install the best solution for our clients. We have a full design service, including the CAT checks. We work a lot with our clients, Reline Europe and with Channel Line, to make sure we can try to resolve any problems we've had. To be truthful, over the last 10 years, we've had very few problems with them at all. We have proven techniques. We have a can-do attitude. We can do everything, or we can just install the liner. But we're looking at trenchless solutions. We're looking at low carbon emission solutions, trying to give you peace of mind, and Channel Line, again, are people we deal with, working all the time, So they're the sort of people that we work with. We've got modern techniques, that we use, and the projects are, low. They're dependent on time, budget. They're cost-effective, reliable, high-quality standards solutions. And just really summarising, so CCTV, cleaning, identification, these are what we offer. Recommending the best engineering solution. Design and engineering verification requirements. CCTV, cured in place linings, GRP, cured in place linings up to 2 meters in diameter. Patches. Pressure liners I explained to you before, that's including the gas, which we discussed. GRP segmental lining, and then brickwork. We can drill new head walls and dismantle head walls and build and do various other things. Concrete canvas is more like a concrete carving. We can use to stabilise banks if we need to. But remember, we are culvert, sewer and pipeline rehabilitation specialists, and it doesn't cost you for us to quote you. So you can send us anything like that. We will give you a quote, and it doesn't cost you any cost at all. And really, that is us. Any questions there then, and I'll pass it back to you, Rosalind, and go from there. Okay, was that okay?
Yes, can you hear me, John?
Yeah, I can, yeah.
Okay, hello everyone. Well, thank you very much. That was very well presented, John. It was really informative and most educational.
Good.
So we're now at the end of today's webinar, and we would just like to put out for 2 more questions. Have we got time for another question?
Yeah.
Okay. Does the product add strength to the pipe culvert in case the pipes totally, sorry?
Yeah, no, the GRP replaces the pipe totally. It replaces it totally. So once that's installed, the existing pipe becomes redundant. It doesn't matter what happens to the existing pipe. It's been replaced by the GRP unit.
Okay. Are you involved with sewer renovation design guide?
Yes, we have
worked by WRC.
Yeah, WRC. Yeah. We use the for the GRP units. Then we use the WRC design criteria. There are 4 professors working on various different designs now, German, French, and that, because they're saying that the WRC may be superseded, but we're still waiting for them. But yeah, with WRC we are involved. As far as the cured in place, we've been involved with them, but we now use the American standard, because the American standard takes into account the loadings, whereas the WRC doesn't take into account the loadings. So it's far more robust. As far as working on the rail and people like that, they want that highways, they want that robustness built in. But WRC are working on it. But yes, we've been working with them on the designs for the last 20 years.
Okay, well, thank you very much. Right, so we'll just wrap it up there. Thank you very much. And thank you very much, everyone, for coming into the webinar today. We're most grateful for that. And we'd just like to say thank you very much for your time. And hopefully we'll be seeing you at other events this year and at the 65th annual dinner in London. And if you could just check out the Pipeline Industries calendar to see for any future events, and you can log in and register for other events. Thank you very much. And thank you very much, John Beach from iLine. Thank you very much again.
No problem at all. Thank you. Thanks very much, everybody. I hope you have a good day.
Thank you. Bye.
Bye-bye.